This is the second part of our notes for Chapter 2, Section 7, Graphing Absolute Value Inequalities. So, how do you go about graphing them? Just like our two-variable inequalities, we have to solve it for y. So make sure y is by itself on one side of the equation. So first, make sure the inequality is solved for y. It must look like this. Y is equal to the absolute value of mx plus b plus c. You will then determine if you have a solid or a dashed line. This is just like the problems we did for the two-variable inequalities, where it took on the form of y equals mx plus b. You're going to use a solid line if it's less than or equal to, or greater than or equal to. It's the equal to that you're looking for, because the points on the line are solutions to the inequality, because the points on, and we'll say the graph, because it's a V-shaped graph, are solutions to the inequality. And conversely, you will use a dashed line if it's simply less than or greater than, but not equal to, because the points on the graph this time are not solutions. And of course, we're going to say not solutions to the inequality. I'm going to abbreviate. We're going to graph the absolute value of the V-shaped graph just like you did for absolute value equations. Just like you did for absolute value equations. But this time our V-shaped graph is going to be our boundary graph. It's actually two lines. We talked already that it's a piecewise function. Okay, just like we did for two variable inequalities, you have to pick a test point. But this time, it's not going to be on one side or the other of the line. It's either going to be inside the V-shaped graph or outside the V-shaped graph. So either inside or outside that V-shaped graph. And you must check these. Check if it's true or false. And again, the original absolute value inequality. And then you will shade appropriately. Okay, if it's true, if the point you pick is inside the V-shaped graph and it's true, then you're going to shade inside. So if true, shade that side, whether it's inside or outside. And of course, if it's false, you're going to shade the opposite. So if I choose a test point inside the absolute V-shaped graph and my result is false, then I have to shade outside. We're going to do 3 examples, and hopefully that'll give you a good jump start to completing your assignment for practice so you can be successful on an assessment. All right, side 2 of this note sheet. We are given y is greater than the absolute value of x minus 2 minus 1. graph the absolute value inequality, and shade appropriately. We are already in y is equal to form. Okay, so it already is taking on that form. So we're going to say y is greater than a times mx plus b plus c. Check. Now we're going to find the vertex because that's our starting point. You know, with the other types of graphs, our starting point was the y-intercept. Here, our starting point is the vertex. And notice that my m here is 1, so I could just say I'm shifting the parent function down 1 and to the right 2. So down 1 to the right 2, you know, that would put me at a vertex over here at this point. So the coordinates for my vertex is 2, negative 1. What is my slope? Well, this thing is opening up because it's positive on the outside, and that's a 1, so my slope is 1, or 1 over 1. So on the right side of the graph, I'm going to go up 1 to the right 1, and I'm going to continue going up 1 over 1 on that side of the graph, and then I'm going to use symmetry to put some points on the other side of the graph. Now I have to ask myself for this problem, is this a solid line or is it a dashed line? Well, I look at my inequality and I see that I'm not equal to, so my line is dashed. And in fact, I have 2 lines here on my absolute value graph. So you can take a straight edge, just put some points in between here so it looks dashed. And I'm going to dash it over here on this side. And then we're going to put arrows on the graph because this thing keeps going. And now the only thing left to do is to figure out what the shading is. So you have to pick a point. I'm going to pick 0, 0 because it's available. See, this line is not passing through 0, 0. So I'm going to test 0, 0. So I'm going to substitute. I'm going back up here to the original problem. 0 is greater than absolute value of x is 0, subtract 2, subtract 1. 0 greater than, well, 0 minus 2 is negative 2, absolute value of negative 2 is 2, and 2 minus 1 is 1. So I have to ask myself, is 0 greater than 1? And you say, no, that's false. Since it's false, I have to shade inside because 0, 0 is outside. So I'm going to come up here and I'm going to shade inside my absolute value V-shaped graph. Okay, the solutions all lie in there. So if you have questions, post a comment on the homework discussion or ask in class. Example number 2 says, graph the absolute value inequality and shade appropriately. Notice this thing does not have y by itself, so I have to solve it. I've got to move the 1 over, and then I have to divide by a negative. So I'm going to show my steps, negative y, excuse me, less than or equal to negative absolute value of x plus 3, and then minus 1. Now I have to divide by negative 1 here. I'm going to divide this by negative 1, and then I'm going to divide this by negative 1. That's going to change the dynamics of my problem. y. When I divide by negative, I have to flip the inequality symbol. Folks, you cannot divide these inside the bars by -1. Okay, so those bars are like caution tape. Do not enter. What I'm going to divide by -1 is this -1 on the outside. You see, that's a -1. So -1 over -1 is +1. This becomes positive absolute value of x plus 3. Okay, don't make the mistake of changing those signs, because that's not what this is happening here. This is a product of these two things. I'm dividing these two. Okay, so in other words, if I divide a negative something by negative, that's going to be a positive that something. Okay, and then -1 divided by -1 is +1. So this is my absolute value inequality in that y equals form. Find the vertex. Well, this again has a 1 as its coefficient, so I can use the transformations to help me find my vertex. This would be the parent function moving up 1 and to the left 3. Up 1, left 3. And it probably would help if you just plot that point so that you can get the coordinates, because I know students are going to mix this up. So I would go up 1 and to the left 3. Now remember, coordinates are x first, then y. So my x is -3 and my y is 1. Okay, so be careful with that. Determine if you're solid or dashed. Well, I do have an equal to, so it's solid. I need my slope. My slope again is 1. And so I can just now go from this point, the vertex point, go up 1 to the right 1, and plot a bunch of points with that same slope. And then on the other side, use symmetry to find the corresponding points, because there's no stretching or shrinking going on here. I'm going to draw my solid line. I'm going to put arrows on my graph to say that it continues. And now I have to do my shading, which means I pick a test point. Again, 0, 0 is up for grabs, so I'm going to choose that. That's one of the easiest points to use. So I'm going to test 0, 0. You don't have to test 0, 0. You could pick a point up here if you want to. But remember, you have to test in the original. This was -y plus 1 less than or equal to the opposite absolute value of x plus 3. I'm testing 0, 0. This -0, well, that's not a thing. That's still 0. This is like -1 times 0 is 0 plus 1 is 1. Less than or equal. 0 plus 3 is 3. Absolute value of 3 is 3, but make it negative, -3. And then ask yourself, is 1 less than or equal to -3? And you say, well, no, that's false. Since it's false, we're going to shade inside, away from the 0, 0. Okay, so I come up here to my graph, and I'm going to shade inside. Not too terribly difficult, I don't think. It's bringing those skills of absolute value along with the inequalities. Okay, last example. Same directions, graph, and shade appropriately. It's not solved for y, so I have to solve it for y. This one's not too bad because I only have to subtract a 1. So y is less than or equal to opposite of 6x plus 3, and then subtract 1. Now, notice, this number is bigger than 1. So I can't just use the 3 and the -1 here to find my vertex. My vertex is found by using the equation, the opposite of b over m, comma c. Well, the opposite of b, what's b? mx plus b, b is 3, over m, what's m? M is 6. What's c? C is negative 1. And so my vertex here, I have to simplify this. This is negative 1/2, comma, negative 1. And that's my vertex. So I'm going to go to where x is negative 1/2 and where y is negative 1. And I'm going to put a point right there. Now, I should identify my slope. This thing is going to be opening down because the leader is negative. So this is 1 times 6, 6, or my slope is negative 6. Solid or dashed? Well, we see it's equal to, so that's solid. And then we're going to set up for a test point. I don't know what I'm going to test yet. I'm going to use my slope of negative 6. So I'm going to fall 1, 2, 3, 4, 5, 6, and run 1. And I'm kind of out of space here. I'm going to use symmetry to get my other point. I know my V-shaped graph is upside down. I know it's a solid line because of the equal to. So I'm going to draw my upside down V. And I have to test a point. I think it's easy to test 0, 0. Okay, so there's my graph that I drew. Again, I went down 6 to the right 1, and then I used symmetry to find the other point. I drew it and put my arrows on, and now I'm testing 0, 0 because the V-shaped graph is not passing through it. Remember, I have to substitute into the original, which is at the top of the page. Y plus 1 is less than or equal to negative on the outside, 6 times x plus 3, close the bar. I'm going to substitute my x and y. 0 plus 1 is 1. Is 1 less than or equal to, well, look at this. 6 times 0 is 0 plus 3 is 3. Absolute value of 3 is 3 times negative 1 is negative 3. Is this true or is this false? Sorry, that's my alarm to remind me to go online for my online students. Okay, so again, is this true or false? And you say, no, that's false. Positive number is never less than a negative number. Where is 0, 0? It's on the outside, so since that is on the outside and it's false, I have to shade inside. Okay, so I'm going to go ahead and shade the inside of that V-shaped graph. Now, if this was true and I'd shade the outside, well then you'd have to shade all of this, okay? But in fact it was false, so I shaded the inside. But again, one more time, if it was true, then you would shade this whole thing on the outside of the graph. So if you have any questions, post a comment on the homework discussion or ask in class. Have a great day.